Hi everybody. This recitation will serve as a review of different modes of convergence that we expect you to know for this course. The three types of convergence that you're expected to know for this course are convergence almost surely, convergence in probability, and convergence in distribution. We're going to go through the definitions of these three types of convergence, and then I'll give you a bunch of examples of different, say, random variable sequences that converge in these ways. Okay. So what I just said is the three types of convergence are convergence, almost surely, convergence in probability, and convergence in distribution. Okay, and the main ones that we're actually going to care about for this course are convergence in probability and convergence in distribution, but in most introductory probability or statistics courses, you'll learn all three of these. So in all three examples, I'm going to have a sequence xn of random variables. Okay, so in the first one, xn will converge to another random variable x, almost surely. Right, and I'll write this like this. If and only if, right, so this is a definition, the probability that, say, xn converges as n goes to infinity to x equals 1. Right, and what I mean here is this is equal to the limit as n goes to infinity of xn equals x. Right, so this is a probability that the limit of the x's equals x, like the probability of that event happening equals 1. Right, maybe this definition is a little confusing just as it's written, but it'll become more clear when I go through an example what this probability actually means. Now a similar one is convergence in probability. It's slightly different, but you'll see sort of what the difference is here. So I write xn, the sequence, converges to x in probability, which I denote by p, if and only if, for all epsilon greater than 0. So fix a number epsilon greater than 0. Then what I need to happen is that the probability that xn minus x in absolute value, right? So the distance between xn and x, the probability that that's greater than epsilon converges to 0 as n goes to infinity, right? Or equivalently, what I mean by this, right, is the limit as n goes to infinity of this probability equals 0. Okay, now you can see maybe that the main difference between these two is in this one, right? The limit is inside the probability. And in this one, the limit is outside the probability. Now finally, what's the last one? The last one is convergence in distribution. This is the weakest of the three. And we say that xn converges to x in distribution if and only if we have pointwise convergence of the distribution function. Right? Here, remember, when I write capital F, I mean the CDF of x. So here, this is the CDF of xn, and this is the CDF of x. Right, so if you can show that the sequence of CDFs converges to this CDF, then we say that xn converges in distribution to x. Okay, so these are the definitions of our three modes of convergence that we care about. Convergence almost surely, convergence in probability, and convergence in distribution. In the coming parts, I will show you some examples of random variables that exhibit each of these modes of convergence, and maybe try to show you some examples where we have, for example, convergence in probability but not convergence almost surely, and convergence in distribution but not convergence in probability. Now I want to note one thing here that I'm not going to prove, but it's pretty easy to find proofs of these facts, either online or in many introductory textbooks. And that's that convergence almost surely, right? I abbreviate almost surely with the A dot S dot. This implies convergence in probability. Okay, so we have this implies this, and we have convergence in probability implies convergence in distribution. Right, so we have this chain of implications where if, for example, some sequence of random variables converges almost surely, we know that it also converges in probability and converges in distribution, but we do not have the reverse implications in general, right? So this is not true in general, and this is not true in general, okay? And some of the examples we'll go through will actually show you why this is the case.